In the standard model of physics, beta decay is treated as a black box. A neutron spontaneously transforms into a proton, and in the process, it creates an electron and a ghost-like neutrino entirely from scratch. We are taught that these new particles simply pop into existence via the weak force. But this is an abstract mathematical concept. It gives us equations, but it provides zero physical machinery for how a discrete object actually materializes out of a vacuum. Refractive cosmology offers a tangible physical cause by redefining the vacuum itself. Space is not an empty void. It is a dynamic, continuous, elastic fluid known as the tau metric. If the universe operates as a highly tensioned fluid, then particle generation is a process governed entirely by deterministic fluid mechanics. Within this fluid model, a neutron is not a solid zero-dimensional dot. It is a high-tension, three-dimensional spherical vortex. Think of it as a complex fluid knot locked firmly into physical space. Because it exists inside a pressurized vacuum, this knot is subjected to immense hydrostatic stress from the surrounding fluid. It is constantly struggling against that external weight, naturally seeking to tighten itself to reach a lower, more stable energy state. A neutron does not randomly decide to decay. It mechanically yields to the crushing weight of the universe. To reach hydrostatic equilibrium, that struggling neutron knot must contract its outer boundary. When it shrinks, it structurally transitions into the slightly smaller, lighter geometry of a proton. But the fluid vacuum imposes strict rules on how a closed loop can change its shape. In continuous fluid topology, this process is governed by Caligari-Ness theorem. The theorem dictates that any knot is held together by an exact mathematical balance of its structural variables, specifically its linking number, twist, and writhe. If you change one variable, the others must mechanically compensate. As the main body of the knot, the writhe, tightens to reach a stable state, the knot physically runs out of room. The excess geometric volume cannot simply vanish. It has to be pushed completely out of the boundary. You cannot squeeze a quantum knot without snapping off pieces of space. The first piece of expelled geometry is the winding number. As the knot tightens, this excess phase volume pinches off from the parent structure to forge a discrete, perfectly stable boundary. We observe this tiny, isolated loop as the electron. But the fluid must conserve absolute physical circulation. To do that, the contracting vortex must violently expel one specific quantum of internal twist. As this spiral of twist shoots outward through the elastic vacuum, it encounters viscous drag. Pushing through the thick fluid forces the defect to swell infinitesimally. That trace volumetric dilation, that physical swelling, creates the tiny inertial rest mass of the neutrino. The neutrino is completely reframed. It is the literal torsional waste product of a stabilizing knot. Looking at the aftermath of this transition, the physical ledger is perfectly balanced. Absolutely nothing was created and nothing was destroyed. The spatial volume of the original neutron perfectly equals the sum of the new proton, the electron, the highly compressed bow shocks of the recoiling fragments, and the trace volume of the neutrino. This table of kinematic nomenclature outlines the exact constants governing this framework. If we focus on the final variable listed here, v tau, we see it defines the absolute physical volume of fluid displaced by a boundary state. In the continuous metric, this displaced volume must remain strictly constant. Beta decay is the absolute one-to-one conservation of physical volume during a structural fracture. This raises a logical question. If neutrons inherently want to untwist and shed volume, why do the neutrons locked inside stable atoms, like the carbon in our own DNA, stay intact forever? The answer lies in a mechanism called acoustic bracing. Inside a nucleus, adjacent protons and neutrons don't sit in empty space. Their outer boundaries merge, establishing a physical transverse fluid tether between them. This shared tether acts as a mechanical shock absorber. It actively braces against the boundary deformation required for beta decay, dropping the probability of structural yield exactly to zero. Particles do not magically materialize in a void. We live inside a meticulously tensioned, interconnected fluid reality, where every subatomic structure and every phantom particle is a necessary geometric mechanism keeping the universe stable.